last time what we have discussed about the normalization. And now, today our agenda is first we will be going to discuss the mean of a matrix or a mean of a data vector. And the subsequent thing that we are going to discuss is standardization. It's something like a normalization. So let's see. Let me share you my screen first. Then we are going to discuss. So the first thing that I'm going to start today is a mean of a data matrix. We already have studied a data matrix, and I will be repeating these things again so that it gets imbibed in your memory. So let me write. It's called mean of a data matrix. This is the first thing that I am going to discuss today. Fine. So now let's assume, let me tell you first thing. Let's assume that we are given a data matrix. So you all know how to draw a data matrix, how to write a data matrix. It's a very simple thing. Let me just write a simple data matrix here. We used to write a data matrix like this. So this is my something like this. So I am drawing. So if you want, you guys can also draw along with me. So if this is something, fine. It looks something like this. So this is my data matrix. And we all know there are certain features inside my data. Column is my features and row is my data points. So let me write it here. Let's suppose this is my F1 feature, F2, F3. Likewise, let's say this is Fj. This is the jth column. And there are, let's suppose, D columns inside my feature. So this is my FD. Fine. And let's suppose this is a data point. So I'm writing data points as 1, 2, 3, so on and so forth. This is my ith data point. And this is my nth data point. And this, I'm giving a representation X as a data matrix. Fine. Everything clear? So if this is, so what is the, how many rows are there inside this matrix? Can anyone tell me how many rows are there inside this matrix?
N.
N. And how many columns are there?
D.
D. So this is a N cross D matrix. Now, let me tell you something. If this is my ith data point, so this is my xi. We already know this. This is my not xi, this is my xi transpose. Why xi transpose? Because by default, our vector is a column vector. So I'm converting it into a row vector. First. And let me take one column here, fj. So let's suppose I'm taking this column, fj. Why I'm taking this column? So you will understand in a while. Suppose if I compute a mean vector, if I want, this is a matrix, and if I want to compute a mean vector, so what I shall do? So for that, let's understand this thing in let's suppose this is my x1. Let's suppose let's suppose I have two vectors, and I'm calling that vectors one as x1 and the second vector I'm calling as x2. These are my two vectors. Fine. Let's suppose, this is just for supposition, if this x1 has some values 2.2, 4.2. Fine. And this x2 has some other values 1.2 comma 3.2. Fine. Now I'm saying this x1, that is this matrix, this vector belongs to R square, and this also belongs to R square. Why both of these belongs to R square? Can anyone x1, why x1 belongs to R square and R2 or x2 belongs to R2? Because in this matrix, in this, matrix not, in this vector x1 and x2, we have only two columns.
D is equal to 2.
Yes, we have only two columns. Since we have only two columns, so this is the value of D is a 2. Because we are talking about D columns. So let's suppose if I do, basically, if let's suppose I want to calculate x1 plus x2. So what I can do? I can do like this. I can do the component wise addition. So this is my first feature. This is my first feature. This is my first feature of x1 and this is my first feature of x2. So I will add both of them. This is called the component addition. So I am adding the first feature or the first component of x1 and the first feature or the first component of x2. So if I will just do this, what is the value that I am getting here? I will get something like 3.4. Fine. And similarly, if I do the component addition of F2 feature, this feature, so I will get something 7. Is this thing clear? Now, if this thing is clear to you, then let me tell you something else. So, this is what the sum of the two vectors mean. Here, this is my first vector, and this is my second vector. And when I'm summing this vector, it means I mean I'm doing a component-wise sum. Now, let's suppose, so I have just, this is to explain you that how to do a component-wise sum. You must be aware of this. Suppose if I compute x bar. Now, what is this? What is this x bar? Also belongs to RD. And we know that x bar is equal to 1 by n summation of xi, where I is equal to 1 till n. Fine. We can also write this as 1 by n x1 plus x2 plus x3, so on, so plus xn. Is it fine? Here, xi belongs to RD. Fine. So this is called basically mean vector. Now let me again explain. So basically, I have defined this x bar. X bar means mean. We used to represent mean as x bar. So this is basically 1 by n summation of xi. Xi means these values. Here xi means there are two xi, x1 and x2. So summation of all from 1 to n. Where we can also write this as 1 by n x1 plus x2 plus x3 till xn. So what actually I'm doing? I'm doing component-wise sum, basically. When I'm doing x1 plus x2 plus x3, what I mean? I am doing the component sum of x1 vector, x2 vector, x3 vector, so on and so on. So each one of the vectors that is present in my data set, I am doing a component-wise sum, and then I am taking the average. This is called mean vector of a data set. Again, each of my xi, this xi, I can say belongs to Rd. Fine. And these are not scalars. These are vectors. So just like we calculate the mean in the scalar quantity, scalar mean, you can say, I can also define a vector mean. Only the thing is that while calculating the vector mean, you have to do the component-wise sum. That is, if let's say this is my x1, fine. If let's say this is my x1, so this x1 has these remaining number of columns, f1, f2, f3, fz till fd. So this is my x2. This is my x3. So what I will do, I will, if I'm doing a component wise sum, so I will sum all the components of x1 till xn. All the components of this, I am doing the sum first. Then I am doing this sum. 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 All the sum, component wise sum of each one of the vector I am doing. And then finally I am calculating the mean. Fine. So I suppose you have understood this thing. Now let me explain you something more here. So this is what a mean means. Now let's understand what does this mean geometrically. So you might ask, what is the geometrical interpretation of a mean vector? So let me explain you this thing with the help of geometrical interpretation. So let's suppose this is first, let me draw, then I will explain you this thing. So fine. Let's this is my what I mean to say. This is suppose f1 I'm giving, and this is let's say h, and this is let's suppose f2, and I am writing it w, height, and this is my weight. Fine. Now let's suppose these are my few data points I'm taking. So I'm taking some data points. This cross represents my data points. So I am writing this cross as my data points. If any one of you will find trouble in understanding, you can simply unmute yourself and ask questions wherever you feel trouble in understanding. Is this thing fine? Now, let's suppose, imagine if I have two features. This is my feature 1, which is a height, and this is my feature 2. So we will understand it, this thing, calculate mean geometrically with the help of 2 dimensions. And why we are I'm using the 2 dimensions just for the simplicity of understanding, because whatever is true in 2 dimension will be true in n dimension. So we will extrapolate the result to n dimension. Fine. So let's assume these are the heights and these are the weight of students, or fine. So each of my xi, each of my xi belongs to Rd. We all know. And what is this? This is my height and weight. So this is a 2-dimensional matrix. We are taking we are taking 2 features. 2 features means 2 dimensions. So height and weight. Fine. Now, this Rd here is, the value of D here is 2. Why 2? Because we have 2 features. Now, the first one is height and the second one is weight. So that's why I am saying this feature as F1 and this is my F2. Now let's come to the what does mean vector represent geometrically. Geometrically, this will be, if I, let's say, write this. So please mute
इतना
yourself.
काम पेंडिंग पड़ा है,
Whoever
मैं
is
तेरे को बता नहीं
speaking.
सकता.
Mr. Sachin, please mute
Yes.
yourself. Please mute yourself. So let's suppose, let's say the mean of this is somewhere here. So what it means? This is a mean point here. On this axis, on the height axis, this is a mean point. If I just do like this, somewhere here, my mean will come. So let's take this as a mean point. And here, this is a mean point. So this is my mean, I can say height. And this is my mean weight. Mean weight. Now, how I am getting this? So what I am doing, basically, if I project all these points, let's suppose I am projecting this point. So if I project all these points on this axis, on my F1 axis or on my X axis, if I project all these points, so I will get point on this axis, something like this. This is just for your understanding. I will get a point something like this. Now, we have these points from here till here. If I project these points on the x-axis, so I will get lot of these points. These are my point, this is my point, this is my point, this is my point, this is something like this. I will get lot of points here. Fine. Now, these points basically are the height of the students. Now, and if I compute the mean height, if I take the mean of these points, I will get mean height somewhere around. So this is my mean height. Where is the mean height? It will become somewhere in between these two extreme points. Here, this will get my mean height. Similarly, when I project these points, let's suppose when I project these points here on this axis, on my y-axis, I will get some of the points, all the points here, 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 and like that. And then if I take the extreme points and calculate the mean, I will get a mean weight somewhere around here. So that's why this is a mean vector. So this point will be my mean vector. Mean vector. Somewhere this point will be my mean vector. Or I can also say this is my central vector. Geometrically speaking, what actually I'm doing, let's suppose I have this, I want to calculate if I write something, this is my mean. What I mean, I want to write h of x bar, comma, weight of x. This is what I mean. Where hx bar is basically mean hi, where I is equal to 1 to n. And wx bar means mean wi, where I is 1 to n. So this is, so that's the simple interpretation of a mean. Mr. Hirak sir.
Yes, sir.
सर ये समझ में आया आपको?
हाँ सर, थोड़ा थोड़ा.
क्यों सर थोड़ा थोड़ा क्यों, पूरा पूरा क्यों नहीं आया समझ? बताइए सर क्या इसमें दिक्कत है?
बिकॉज थोड़ा सा समय लगेगा सर, क्योंकि ये वर्टिकल नहीं है ना मेरे, थोड़ा समय लगेगा.
अच्छा,
डोंट बिलोंग्स टू मैथमेटिक्स वाला.
मतलब आप सिंपल सा बात, ये हम मीन कैसे कैलकुलेट करते हैं नॉर्मल, तो बस इसको हम वेक्टर्स के टर्म्स में बात कर रहे हैं कि वेक्टर्स के टर्म्स में कैसे मीन कैलकुलेट करें. सिंपल, अगर मुझे, अगर
दिस
मेरे
इज
पास
क्लियर, दिस स्लाइड इज क्लियर विच यू आर शोइंग. that is summation of 1 by n summation of xi. This is clear to me.
ठीक है,
There is no issue. The next slide, इसमें थोड़ा सा ना कॉम्प्लेक्सिटी है, तो इसमें
नहीं मैं आपको समझाता हूँ, इसमें कुछ नहीं है। संजीव सर आपको समझ आया सर? संजीव सर नहीं है। देखिए सर, मैं ये कह रहा हूँ कि ये सारे मेरे पास डेटा पॉइंट्स, ये जो क्रॉस है, रेड रेड में जो क्रॉस है, ये डेटा पॉइंट्स है, ठीक है सर।
हाँ।
अभी ये डेटा पॉइंट्स का दो फीचर्स, हाइट और वेट, ये दो फीचर, ये समझ में आया आपको?
हम्म।
अभी मुझे इन सारे डेटा पॉइंट्स का मीन निकालना है।
हम्म।
अभी मान लीजिए कि आपको मैं नंबर दूं 1 2 3 4 5, ये मेरा रैंडम, मैंने 5 नंबर दे दिया। हम इसका मीन कैसे कैलकुलेट करते हैं? सम ऑफ द टर्म्स
5 4
प्लस
3
टू
2 1 का
थ्री
सम
फोर
डिवाइड बाय 5।
डिवाइडेड बाय 5, मतलब
हाँ।
सम ऑफ द टर्म्स बाय
हाँ।
नंबर ऑफ टर्म्स।
हाँ।
तो ये तो हमारा स्केलर है, क्वांटिटी। तो
हम्म।
स्केलर में हम ऐसे निकालते हैं। लेकिन यहाँ क्या है कि ये वेक्टर है, और इसीलिए मैंने बात किया कि वेक्टर का मीन कैसे निकालते हैं। वेक्टर में जब हम सम करते हैं, सम का मतलब क्या होता है कि कंपोनेंट वाइज सम। जैसे अगर ये मेरा एक वेक्टर है, लेट सपोज ये सर मेरा एक वेक्टर है x1, और इस वेक्टर के दो कंपोनेंट हैं, मतलब दो फीचर्स हैं। तो और अगर मैं x1 प्लस x2 करूंगा यहाँ, वहां तो हमने सिंपल कर दिया। बट यहाँ क्या है कि इसका फीचर और इसका फीचर को ऐड करना है,
हम्म।
इसका फीचर और इसका फीचर को ऐड करना है।
हम्म।
तो जो मुझे रिजल्टेंट वेक्टर मिलेगा वो मिलेगा x1 प्लस x2।
हम्म।
ऐसे ही अगर मेरे पास मतलब n नंबर ऑफ वेक्टर्स है, समझ रहे हो आप? अगर
हम्म।
n नंबर ऑफ वेक्टर्स है तो मैं सारे वेक्टर्स को प्लस करूंगा,
करेक्ट, f1 प्लस
f2 प्लस f3, और उसका जो मिड होगा, जो बीच का वैल्यू होगा, डिवाइडेड बाय n करूंगा। अभी मैंने क्या किया, इसको सर, ये जो मेरा डेटा पॉइंट्स हैं, इन सब डेटा पॉइंट्स को मैंने
हम
प्रोजेक्ट कर
इसमें
लिया।
सर हम यही करेंगे ना, उसका फॉर्मूला ये बनेगा ना, x1 f1 प्लस x2 f1 प्लस x3 f1।
बिल्कुल बिल्कुल।
करेक्ट,
करेक्ट।
सेम फॉर x1 f2 प्लस x2 f2 प्लस
बिल्कुल
x3 f2।
बिल्कुल बिल्कुल। तो
करेक्ट।
मैंने क्या किया, इसको सर प्रोजेक्ट कर लिया। इसके बाद मैंने मीन निकाल लिया, कहीं यहाँ मिलेगा, इस पॉइंट्स को इधर इस एक्सिस पे प्रोजेक्ट किया, इसका मीन। तो इन दोनों का जो एक्चुअली यहाँ कहीं मीन मेरे को मिल रहा है, वही मीन होगा। बस
हम्म।
इतना ही बात किया इसमें।
हम्म।
ठीक है सर। अब हम नेक्स्ट जो कंसेप्ट करने वाले हैं वो बेसिकली क्या है, कॉलम। दिस इज बेसिकली अ डेटा डेटा प्री प्रोसेसिंग, प्री प्रोसेसिंग। सो डेटा प्री प्रोसेसिंग में, if you would have remembered, so first thing that we have done is column normalization. अभी हम क्या करने वाले हैं, कॉलम स्टैंडर्डाइजेशन, स्टैंडर्डाइजेशन। ठीक है, कोई मुझे बता सकता है कि कॉलम नॉर्मलाइजेशन में हमने क्या किया था? एनी वन ऑफ यू, थोड़ा बहुत भी आइडिया हो?
Then we put all the values between 0 and 1.
Correct. We have converted the my feature column in such a way
Between 0
that
and
the
1.
value lies between 0 and previous sessions. So in column normalization, what did we actually do? So we took each column. Fine. So let me, and then we compressed all the values inside that column between 0 to 1. So into a unit hypercube. We have talked about the unit hypercube. And so that to get rid of scales of each feature. And we created our own scale where all the values lie between 0 and 1. That's what we did in column normalization. Is this thing clear? So let me write this form. In column normalization, normalization, what we have done, we converted the values between 0 and 1. And why we have done this? To get rid of scales of each feature. Fine. In column standardization, we basically standardize each column. There we are normalizing. Here we are standardizing each column. So let us see how to standardize one column of data. So here, let's suppose I am taking this column, Fj, this feature column. And let's say I have A1, A2, A1, A2, A3, likewise, this is my AI, and likewise, this is my AN. So these are the n values of feature J. And similarly, like this column, I have other columns also, like F2, F3, F4, so on, columns. So I'm just showing you how to do column standardization for one column. The same thing needs to be done for other columns as well. So in column standardization, what I do is, let's suppose this is my raw data. This is the data of one of my column, Fj column. And it could be, this data could be in any scale. It could be in kilogram, inches, or whatever. I don't care about this scale. So what I will do, what I'm going to do basically is, I'm going to convert this. If we just put this thing a little bit this side, I can find more space to write. Okay. Now, let's suppose I'm having this column of data A1, A2, A3, AI, and till AN. Fine. So if I am having this column of data, so let me close it. Fine. So I know there are n values of Fj, n values of Fj feature. I know that. After doing the column standardization, I'm writing this short form. Let's suppose my data are A1 dash, A2 dash, A3 dash, so on, AI dash, and AN dash. Clear? So what I have done, I have converted this into A1 dash, A2 dash, A3 dash, AI dash, and so on and so forth, AN dash. Just like we did in normalization. So in normalization, all transformed values of A1 dash, A2 dash fit in a unit hypercube, and all the values lie between 0 and 1. But here there is a subtle difference. So in the transformed data, what is the difference? I will ensure that the mean of my standard data, that is mean of AI dash, that is mean of my transform data, where I is equal to 1 to n is equal to 0. And my standard deviation of my AI dash will be equal to AI dash where I is equal to 1 till n is equal to 1. This is the main thing. Now, let's understand this thing. Let me explain you this thing again. So, in the transform data, so I have transformed the data from A1, A2, A3, AI, AN to A1 dash, A2 dash, A3 dash, AI dash, and AN dash. But what if, when I have transformed the data, I make sure that the mean of my transformed data, that is mean of this AI dash, should always be 0, and the standard deviation of this AI dash is always 1. Fine. So what does column standardization does exactly is, it converts your data points such that the mean of the transformed data is 0 and the standard deviation is 1. And this is not boxing all the values here, what we did in column normalization. In column normalization, we ensure that all your A dash lie in interval 0 to 1. That's what we have discussed. All this value lie between 0 to 1. But here, it's something in standardizing, we are converting into a form such that the mean of AI dash is 0 and the standard deviation is equal to 1. So here I am saying, instead of all my values lying between 0 and 1, I want the mean to be 0 and I want standard deviation to be 1. Fine. Now, here I am not assuming anything about the distribution of this A1, A2, A3, AN. Whatever be the distribution, this can come from any distribution. This is not necessarily a Gaussian distribution. This may be any distribution. Now you must, some of you are wondering what is this Gaussian distribution and what is this distribution? We have not studied till. That's why statistics is a very integral part of machine learning. So before you should start learning machine learning, you should do statistics part of it, because statistics is used in machine learning. So this is, if any one of you who wants to study statistics part, you can go to my playlist on my YouTube channel by the name Statistics for AI and Data Science. And you can, I have discussed all these things in a sequence inside that playlist, and still this playlist is going on. So I will be updating that playlist with a lot of more concepts. So you can watch these things from there. Fine. It will be very helpful for you in understanding the machine learning. Fine. So what actually I have done is, let's see how to do this. Let's define, let me define this thing. So let's do one thing. Let me explain you this thing. Let's define, this is AIs. So what is my, let's say this is my A1, this is my A2, this is my A3, so on so forth. This is my AI and this is my AN. Fine. So this may be from any distribution. This may be from any distribution. This is not necessarily a Gaussian distribution. Now, if I simply apply the column standardization here, standardization, I am writing the short form, I will get A1 dash, A2 dash, A3 dash, likewise AI dash and AN dash. Yes. Such that when I'm writing this, such that the mean is equal to, mean of this is equal to 0 and the standard deviation is equal to standard deviation equal to 1. Fine. One very important thing that you should know, this A bar is basically the mean of AI. Fine, where I is equal to 1 to n. And this is my sample mean. Sample mean. And I am representing the standard deviation by small s, and my standard deviation is basically AI I is equal to 1 till n. And this is my sample standard deviation. So if I have to actually write AI dash, this is basically the formula to calculate AI dash, AI minus A bar by smalls. So what it means? It simply means mean of, I will explain you, just let me write it first. AI dash is where I is equal to 1 till n is equal to 0, and the standard deviation of AI dash I is equal to 1 to n is equal to 1. Now, let me explain you all these things, because this is, otherwise you will get confused what all these things is. So let me explain you whatever I have discussed. So what I am telling you, this is, A1 till AN, and this can come from any distribution. After column standardization, we are getting A1 dash, A2 dash till AN dash. And what is after column standardization, if I am getting this thing, so the mean of these values should be 0 and the standard deviation is 1. Then only we are applying the column standardization. So after that, this A bar, basically this is my A bar is basically the mean of AIs. That is mean of all these A's, where I is equal to 1 to n. And this is basically my sample mean. So this is not sample means this is not population mean. From the probability, I have discussed this thing in my very first actually session in the statistics for AI and data science playlist, that what is population, what is sample. So from the probability section, you will remember what's the difference between the sample and the populations. Fine. And this is this small s, I'm representing this small as a standard deviation, where AI is equal to 1 to n, and this is also not population, this is sample standard deviation. Fine. Now, let's suppose if I am given a few points or a bunch of vectors, I can compute the mean very easily. We have understood. I can also compute the standard deviation in the same way. So how to calculate? So this is a representation for the standard deviation. Now, what is this AI dash? This is, I have taken this AI, that is, this AI means this values, then minus A bar. This A bar is basically my sample mean. And this is my standard deviation. So I have taken this, I have used this formula where AI minus A bar by standard deviation. So if you recall, when we learned about standard normal variate. So, and this is I have already explained you. So let's see what we have learned during standard normal variate. So if you remember, let me write it here. If you remember, so the formula is AI dash is equal to AI minus A bar by small s, that is this. And this AI should come from any distribution. Any distribution. Distribution. And this AI basically mean is equal to here 0 and my standard deviation is equal to 1. This is the case that we are seeing right now here. Now, here let me give you the another scenario to recall you the standard normal variate. So this is the standard normal variate. We have studied this thing also in statistics, and this is represented as Z. Fine. So this standard normal variate, the formula of this standard normal variate was X minus mu by sigma, where X basically belongs to my normal distribution or Gaussian distribution with mu and theta, and Z also belongs to my normal distribution 0, 1. This is basically this 0 is my mu, and this is my sigma. Let me write it. This is my
सर हेलो
yes.
हाय अनूप सर, कैसे हैं आप?
बढ़िया सर.
सर मेरा एक क्वेश्चन है जो आपने लिखा हुआ है डायमेंशनलिटी डिडक्शन, राइट, इन एमएल।
हाँ,
ये जो टॉपिक आज हम पढ़ रहे हैं, इसका मेजर जो यूज किया जाता है, तो वो किस पर्पज में हम लोग इसको मतलब क्या यूज केस होता है इसका इन टेक्निकल टर्म्स में?
ठीक है सर, हम इसको देखेंगे. पहले अभी हम जो कॉलम स्टैंडर्ड नॉर्मल वेरिएट और ये कॉलम स्टैंडर्डाइजेशन समझ लेते हैं. इसके बाद हम एंड में इस क्वेश्चन को ले लेंगे. अभी जो हम डिस्कस कर रहे हैं इस टाइम पे, उससे कोई अगर आपको डाउट्स है तो प्लीज आप उसको अभी पूछ ले. बाकी वो हम एंड में आपको उस
थोड़ा
डाउट
मैं
से.
उससे मतलब थोड़ा समझ नहीं आ रहा था कि मैं एग्जैक्टली थोड़ा सा चीजें इसलिए आपसे पूछ रहा था मैं.
अभी वी आर इन बिटवीन समथिंग, तो हम इसको पहले एक बार डिस्कस कर ले, फिर आपका, क्योंकि वो डाउट्स अलग ही डाउट्स है, तो उसको हम अलग से सेपरेटली देखते हैं. लेट मी फिनिश दिस थिंग फर्स्ट. ठीक है सर. तो सर ये स्टैंडर्ड नॉर्मल वेरिएट हमारा क्या है बेसिकली. सो दैट वी हैव लर्न द स्टैंडर्ड नॉर्मल वेरिएट विच इज ऑल्सो कॉल्ड Z. ठीक है. एंड वी नो दैट दिस Z is basically Z is nothing but X minus mu by sigma, where what I have said, X is basically normally distributed with mu and sigma. And if I construct my Z like this, then Z will be also be normally distributed with mean 0 and standard deviation 1. So if some of you have understood clearly the statistics part, so you will understand that these two, this thing and this thing, looks very similar. This is AI. This is basically my X, which is basically Xi. This is my A bar. A bar means mean of all the values. This is my mean. And this is my sigma, which is also standard deviation. And this is also my sigma. Only the thing is that this is my mu and sigma, and this is a standard, this is my mean and this is my standard deviation. Fine. So this mean is 0 and this is my standard deviation is 1. So these two things look very similar. But remember, this thing is very important. Here, AI could be from any distribution, but here in the standard normal variate, this is basically my normal distribution or Gaussian distribution. This is the main difference between standard normal variate and this standardization. Correct? Now, when we are applying the idea from the standard normal variate to transform my data such that AI dash has a mean of 0 and a standard deviation of 1. What I mean by applying this transformation, I am creating a new random variable here, which has a mean of 0 and a standard deviation of 1. So it looks exactly similar that we have already seen. This is why it's called standardization. And this is called standard normal variate. Fine. Now, one very important thing here is that how this is useful geometrically. So how we can see these things geometrically, because until unless we will understand this geometrically, we will not get a clear picture in our mind. So are you guys ready to understand how this looks geometrically? Can I get a quick yes or no from you guys? And this is, let's suppose F2 is equal to W. And let's suppose this is my data points. So these are my data points. This cross is basically my.
अनूप सर,
Yes, sir.
एक क्वेश्चन जो ऊपर वाली स्लाइड है उसमें एक साइन यूज किया है आपने, उस साइन को क्या बोलते हैं?
इस साइन, कौन से साइन को सर?
जो ये z इज इक्वल टू n किया हुआ है आपने, जो ये जो साइन किस टाइप का साइन है?
ये जेड,
हाँ यही नहीं, आगे नीचे वाला थर्ड
ये
नंबर पे, हाँ इससे
ये
नीचे, हाँ इसके जो बीच में साइन है
ये
हम्म
इसका मतलब होता है बिलोंग्स टू। इसका मतलब
ओके
होता है, इस साइन का मतलब होता है बिलोंग्स टू।
ओके
बिलोंग्स टू मतलब z belongs to normal distribution,
ओके
x belongs to normal distribution. इसका मतलब हुआ x belongs to normal distribution, और नॉर्मल डिस्ट्रीब्यूशन में दो चीजें आती है, मीन आता है एंड स्टैंडर्ड डिविएशन आता है। ठीक है। अब जब मैं ये कह रहा हूं कि z belongs to normal distribution, तो ये मीन इज इक्वल टू 0 and 1 हो जाता है।
सर मुझे, सर सॉरी आपको इंटरप्ट कर रहा हूँ,
एंड हाँ बताइए।
हम लोग जब मैट्रिक्स पढ़ते थे 12th में, राइट, तो ये साइन मैट्रिक्स के में यूज किया जाता था क्या? मेरे को बिल्कुल भी रिमेम्बर नहीं है।
तो अगर आप सर अगर आप देखेंगे तो आज जो फर्स्ट पार्ट में मैंने यही सारी चीजें डिस्कस किया है। ठीक है। मीन ऑफ ए डेटा मैट्रिक्स, क्या आप देख पा रहे हैं मेरा ये स्लाइड?
हाँ 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 हाँ
तो ये हमारा मैट्रिक्स है,
राइट।
और हम यही सारी चीजें अभी पूरा फर्स्ट हाफ में मैंने यही सारा एक्सप्लेन किया है कि एक मैट्रिक्स के अंदर अगर हमारे पास वेक्टर्स होंगे, मैंने इसको 2 डायमेंशनल वेक्टर्स को लेके दिखाया, तो हम उसका मीन कैसे कैलकुलेट करते हैं। अगर हमारे पास सिंपल कोई नंबर है, लेट्स से 1 2 3 4 5, तो हम इसका मीन कैसे कैलकुलेट करते हैं? 1 + 2 + 3 + 4 + 5 डिवाइडेड बाई 5, ये मीन हो जाएगा। स्केलर के केस में ट्रू। बट अगर हम वेक्टर की बात करें, तो वेक्टर के केस में हम लोग कैसे कैलकुलेट करते हैं, उसका मैंने पूरा ही फर्स्ट हाफ में ये सारा ही वही डिस्कस किया। ठीक है, कैसे
तो सर दिस इज पीसीए मेथड या एमडीएस मेथड? ये पीसीए मेथड है या एमडीएस है?
एमडीएस क्या होता है?
आई थिंक डिस्टेंस मेट्रिक कुछ ऐसा है शायद में।
हाँ,
नहीं, मैंने कहीं पढ़ा था कि दो मेथड होते हैं, पीसी और एमडीएस ना। इस
एमडीएस तो कोई मेथड मुझे नहीं पता है।
ओके।
पीसीए होता है प्रिंसिपल कंपोनेंट एनालिसिस, अभी
हाँ।
वहां पे पहुंचे ही नहीं है सर।
ओके
अभी तो
ओके।
हम बस उसके लिए तैयारी कर रहे हैं, हवन कर रहे हैं, ये छोटे छोटे कॉन्सेप्ट समझ रहे हैं।
नहीं
फिर
सर, मेरे
बाद
को आज मैट्रिक्स क्लिक हुआ ना, तो मैं थोड़ा इस वजह से
नहीं
कि
सर,
सारा रिलेट
आप
कर पा रहा था थोड़ा बहुत।
हाँ, तो हम अभी वहां पे पहुंचे ही नहीं है। पीसीए पे तो
ओके।
हम पहुंचे नहीं है, पीसीए को समझने के लिए ये सारी
अब
चीजें।
थोड़ा रिलेट हुआ ना सर, मैं समझा जो साइन आपने बोला
तो
ना,
क्या
बिलोंग्स
है
टू
कि सर
नेचर,
मैं
मैंने।
बताता हूँ आपको, पीसीए को समझने के लिए अभी ये सारे छोटे छोटे कॉन्सेप्ट्स हैं, पहले हमको
राइट
उसको
राइट।
समझना होगा,
हाँ।
देन हम पीसीए को समझेंगे। तो
ओके।
इसके लिए मैं हमारा एजेंडा था डायमेंशनलिटी रिडक्शन टेक्निक के अंदर दो टेक्निक हम यूज करने वाले हैं, पीसीए एंड टिस्ने। ठीक है,
हम्म
लेकिन उन दोनों को पढ़ने के लिए, समझने के लिए, यू नीड टू अंडरस्टैंड द बेसिक्स बिहाइंड इट।
हम्म
अनटिल अनलेस आपको बेसिक्स कंसेप्ट पता नहीं होगा, अगर मैं सीधे स्टार्ट कर दूं अभी पीसीए समझाना, यू विल नॉट गेट इट। तो
हम्म
डेट
हम्म
में
हम्म,
मैंने क्या किया, मैंने बहुत ही बेसिक्स से स्टार्ट किया। अगर आप मेरे बेसिक्स इससे फॉलो करोगे तो आपको समझ आ जाएगा कि हमने कहाँ से स्टार्ट किया। ये देखो सर, हमने पहले डायमेंशनल रिडक्शन क्या होता है, क्या करते हैं, ये सब, ये सारी चीजें हमने एक एक चीजें, रो वेक्टर, कॉलम वेक्टर, फिर हमने आइरिस फ्लावर डेटा सेट को, डेटा सेट समझा कि उसको कैसे रिप्रेजेंटेशन, फिर हम डेटा सेट को मैट्रिक्स के फॉर्म में कैसे रिप्रेजेंट करेंगे वो सीखा। फिर हम डेटा प्री प्रोसेसिंग में कॉलम नॉर्मलाइजेशन पढ़ा, स्टडी किया, उसके अंदर ये सारी चीजें स्टडी किया, उसका
तो सर हमको जो
ज्योमेट्रिक।
बेसिक मैट्रिक्स होता है वो समझना भी जरूरी है क्या पहले, मतलब साथ के साथ पैरेलली, बेसिकली?
हाँ बिल्कुल जरूरी है, अदरवाइज यू विल नॉट अंडरस्टैंड पीसीए।
है ना?
अगर
मतलब
आपको
बेसिक
बेसिक
मैट्रिक्स हम लोग
मैट्रिक्स,
जैसे 12th में हमने जो जो थोड़ा बहुत स्टडी किया, अभी तो बिल्कुल ही ब्लैंक हो गया है, राइट?
नहीं सर,
ओके।
अगर आप मेरा फर्स्ट सेशन से फॉलो करते तो
हम्म।
आपको कोई कहीं कुछ समझने की जरूरत नहीं है, बस आप इसको
ओके
अगर फॉलो करते तो आपको सारा समझ में आ जाएगा। बट फॉर
ओके
दैट यू हैव टू फॉलो फ्रॉम द वेरी फर्स्ट लेक्चर।
ओके ओके।
अगर आप लेट्स से कि अभी आपने एकदम से सडनली आ जाओगे तो डेफिनेटली यू विल नॉट अंडरस्टैंड।
हम्म।
यही तो मैं आपको समझा रहा हूँ कि ये चीजें अगर आप मेरे फर्स्ट सेशन को फॉलो करेंगे, क्योंकि वो सारी चीजें इंटरलिंक्ड है ना सर। अभी
हम्म।
पहले मैंने कॉलम नॉर्मलाइजेशन समझा, फिर मैंने कॉलम स्टैंडर्डाइजेशन समझाने से पहले पहले मैंने क्या किया, आज मीन समझा कि कैसे हम लोग मीन ऑफ ए वेक्टर डेटा मैट्रिक्स निकालते हैं। क्योंकि
ओके।
मीन, जब हम कॉलम स्टैंडर्डाइजेशन की बात कर रहे हैं तो मीन का कंसेप्ट आएगा, स्टैंडर्ड
हम्म
डेविएशन का कॉन्सेप्ट आएगा। तो आपको अगर मीन नहीं पता होगा तो आप कॉलम स्टैंडर्डाइजेशन नहीं समझ सकते हैं।
हम्म
आपको अगर स्टैंडर्ड डेविएशन नहीं समझ में आएगा तो आपको दिक्कत होगी। तो ये सारी चीजें लिंक्ड है। फिर
हम्म
हमने जब यहाँ पे डिस्कस कर लिया, फिर मैंने इसको बताया कि मैंने एक कंपैरिजन बताया कि ये जो हम कर रहे हैं और स्टैंडर्ड नॉर्मल वेरिएट में का फॉर्मूला एक ही जैसा है, सिमिलर है।
हाँ।
बस डिफरेंस क्या है कि यहाँ एआई किसी भी डिस्ट्रीब्यूशन से हो सकता है। अब आप पूछोगे
हम्म
डिस्ट्रीब्यूशन क्या होता है, तो यू हैव टू अंडरस्टैंड द स्टैटिस्टिक्स पार्ट ऑफ इट, विच इज वेरी इंपॉर्टेंट। बिना
हम्म
स्टैटिस्टिक्स का आप मशीन लर्निंग आपके लिए दिक्कत होगा समझना। फॉर दैट
हम्म
इज अ प्लेलिस्ट, यूट्यूब पे मेरा प्लेलिस्ट है, स्टैटिस्टिक्स फॉर एआई एंड डेटा साइंस। इफ यू फॉलो दैट प्लेलिस्ट यू विल अंडरस्टैंड दीज थिंग्स वेरी वेल। ठीक है, और आप कहीं से भी पढ़ सकते हैं। दिस इज नॉट कि आप मेरी प्लेलिस्ट से पढ़े, यू कैन गो एनीवेयर एंड सर्च ऑन द इंटरनेट एंड यू कैन स्टडी। तो मैंने ये बोला ये यहाँ सिर्फ किसी भी डिस्ट्रीब्यूशन के लिए ट्रू है, बट
हम्म
दिस इज ट्रू ओनली फॉर द नॉर्मल डिस्ट्रीब्यूशन ऑफ गॉसियन डिस्ट्रीब्यूशन। अब आप पूछोगे नॉर्मल डिस्ट्रीब्यूशन क्या होता है, गॉसियन डिस्ट्रीब्यूशन क्या है, अगेन देयर इज स्टैटिस्टिक्स पार्ट ऑफ इट, आपको
हम्म
समझना होगा। अदरवाइज इफ यू विल नॉट अंडरस्टैंड देन दी यू विल नॉट अंडरस्टैंड दिस। अब मैं पीसीए पढ़ा रहा हूँ, अगर अब मैं यहाँ पे स्टैंडर्ड नॉर्मल डिस्ट्रीब्यूशन पढ़ाने लगूंगा तो इट विल टेक अ कंप्लीट लेक्चर,
हम्म।
अंडरस्टैंड दैट वेरी कॉन्सेप्ट। तो इसलिए चीजें लिंक्ड हैं, मैं ये कह रहा हूँ सर।
ओके, नहीं नहीं, गॉट इट योर पॉइंट सर, थैंक यू सो मच फॉर योर वैल्यूएबल इंफॉर्मेशन।
थैंक यू सर। तो अभी हम लोग इसके ऊपर ज्योमेट्रिकली समझते हैं कि इनका क्या ये है, इसको समझ के फिर हम आगे बढ़ते हैं सर। तो ये मेरा डेटा पॉइंट्स मैंने बना दिया। अब इसके बाद मैं लेट्स सपोज इसको मैं प्रोजेक्ट कर रहा हूँ यहाँ, एंड इसको मैं प्रोजेक्ट दिस line, and let's project this line here। ठीक है, तो let's suppose this is my and here इसको मैं यहाँ प्रोजेक्ट कर रहा हूँ। सिमिलरली ये सारे पॉइंट्स को मैं जब प्रोजेक्ट करूंगा, आई विल गेट दिस पॉइंट्स। सो लेट्स अंडरस्टैंड what I'm telling you, just imagine I have two features. This is my height, h means height, and this is my weight. This is a two-dimensional vector that I am right now discussing, which is height is my one feature and weight is my second feature. And these could be in any scale. I don't care what the scale is. So let's assume that these are the heights and weights of students of a school or a class or a college, whatever. So where does the mean of these data? This is a data. So where does the mean of this height could lie? It could lie anywhere. Let's suppose this is my mean point. Fine, this is my mean point. So let's see if this is my mean point. So this is a mean height. Mean. So now how I am getting this mean height? Mean height is basically I am projecting all these points, and these are my, let's suppose, projected points. These are the projected points. And by considering all these points, I am calculating the mean height. Similarly, let's suppose I am projecting these points on the y-axis, that is F2 axis. So I am getting these projected points here. Fine. And somewhere here I am getting the mean. Let's suppose this is my mean point. This is my mean weight. Mean weight. Is this thing clear to you or not? Now, so if I project simply this point, I will get something, this point. This is my mean point. Fine. This is my variance. So on the height axis or on the x-axis, this is the variance of my data. That is, this is the spread of my data. So what is the spread of my data on the x-axis? This is the spread of the data on x-axis. And this is the spread of the data on y-axis. Fine. So if let me write it, this is the spread of my data on the y-axis, and this is the spread of the data on x-axis. And what is the spread? Spread is basically a variance. The more the spread, more will be the variance. Now you will again say, what is this variance? So you have to understand the statistics part of it. Then you will understand, come to know what is this variance. So I'm not saying variance is a width, because I cannot show it geometrically on 2D, but this is just for your understanding. So variance measures how spread your data is. How I am measuring the variance? By projecting all these points on the x-axis and this on the y-axis. So this is the variance of the weight, and this is the variance of the height. Fine. So, and when I have calculated the mean of all the projected point, this I am getting the mean height, and this I am getting the mean weight. Now, since standard deviation is basically, if you recall the formula of standard deviation is basically square root of the variance, as you know. So by transforming this using column standardization, what we get? I get a new data set. So when I am performing column standardization on this data, this is my original data. And I am performing column standardization on this data. This is the geometrical representation of my original raw data, F1, F2 features, that what I have told you. This is my, let's suppose this is the original before column standardization. This is my geometrical representation. Now, when I am performing the column standardization, what I am getting a new data set. So I am calling this new data set. Let me call this new data set as F1 dash is equal to H dash, and this is my F2 dash is equal to W dash. Are you getting my point? Now, I told you that through column standardization, I'm going to get a mean of 0, which means this point, this point, which was my original mean, it is somewhere here. This mean has some height and some weight, which is my original. So, since after column standardization, I'm going to get a mean of 0, which means this mean will move to this point, 0, 0. So if this will move to this point, so what will be my, let's, data distribution? My data distribution will be something, let's suppose, like this. Let's suppose something like this will be my data representation. Why? Because this will be my mean vector. Mean vector. And what will be my mean vector? 0, 0. Sorry, 0, 0, not 0, 0, 0. Which means this is my origin. So what I am doing, so my new data, after getting transformed, after doing column standardization, my new data will look like this. Can you see? Now, my mean vector, this is the mean vector. This mean vector will be at 0, 0, since it's a 2 dimension. If it will be a high dimension, then we can say it will lie at origin. Fine. So what I have basically done, I have moved all these points such that the mean moves to 0. And I have also ensured that I squeeze these points. If this is the mean, so first thing, first thing I did was I moved my mean center to here. This is my first thing. I have moved my mean from here to this point, 0, 0. Then, if when I move my mean, so then comes the standard deviation or the spread. So that so what is the spread that I get on the x-axis right now? See, earlier I was getting this spread on the x-axis, this thing. This was my spread. And this was my spread on the y-axis. Now, after doing this, let's see, this will be my this thing, this thing, this thing, this thing, and this one. These are basically my spread. So now my spread will be, this will be my spread, and this will be my spread. My spread on the y-axis will be this. This will be my spread on the y-axis, and this will be my spread on the x-axis. Such that this the standard deviation is equal to 1. Standard deviation is equal to 1. Fine. So literally what I'm doing here, first step, I'm moving my mean vector to the origin. And the second is, I am either squeezing or expanding, because my standard deviation should be 1. So if my standard deviation is 1, this is my standard. If my standard deviation is 1, suppose let's say my variance here is, let's say 0.5. Let's suppose if I'm getting a variance 0.5. That is, my spread is this thing. So my standard deviation is also, let's say, this thing. So then, since I need to have a standard deviation of 1, and after doing this, my standard deviation is only 0.5. So my sample, so I need to expand these points. Because what is the guarantee here? The guarantee is my transformed space is such that the standard deviation is 1 on my axis. So if my standard deviation is less than 1, I am going to expand these points. Are you getting? And that is, I am going to pull these points, stretch these points away. And if my standard deviation is, let's say, is more than 1, let's suppose if my standard deviation is 5, in that case, I need to squeeze. I'm going to squeeze such that the standard deviation for any feature will 1. Because ultimate goal is to make the standard deviation 1. So if a standard deviation is less, I have to stretch. If a standard deviation is more than 1, I have to squeeze. This is the essence of column standardization geometrically. Fine. I repeat this just for the clarity. And first, let me write these important points about this column standardization. Important points. First thing is that I'm moving the mean vector to origin. Moving the mean vector to origin. And the second thing is the squeezing or expanding. Fine. So I'm going to repeat it once again, just for the clarity. So what I'm doing here, I'm moving my mean vector to origin, and I might as well squeeze points or expand these points. As will squeeze it. If the standard deviation is greater than 1, I will expand it. If the standard deviation is less than 1. So I have to make the standard deviation equal to 1 on every axis, on both the axes, I mean, on your F1 dash axis or F2 dash axis. Now, this is also called mean centering. So what is this mean centering? Is basically, this is, let me explain you this mean centering. This is same thing. So basically, this column standardization is standardization Deviation is basically by mean centering, that is making at origin plus scaling. Scaling means standard deviation for all features is equal to 4. This is what I mean. We will see why column standardization is very useful when we will learn PCA. So, which is very important. That's why I am spending so much time in discussing the basics of PCA so that you will not find a difficulty in understanding the PCA. Is this thing clear to you, guys? Have you understood? So let me stop.
आपको कैसे पता नहीं समझ में आया?
नहीं नहीं, मतलब समझ तो आया आपको,